Okay, so we're carrying on talking about refraction and lenses. So we have our convex lens here, which is fatter in the middle than it is on the edges. And we can see that the light has refracted in this downward direction at this location and also at this location. Now we move on to talk about what happens to light at the bottom of this lens that enters at this angle using our analogy that we were using earlier of um, our shopping trolley, we have our wheel entering the glass, which is going to slow down light, and this side of light will enter first and slow down. This side of the light ray will continue to move at the same speed, so therefore we will have a refraction upwards, and the same thing is going to happen again. So what we've done with this convex lens is we have brought the light rays into a focus point at this location here. And this here is going to be called the principal focus. Now, the angle of which the refraction occurs, and so therefore the distance that this principal focus will be away from the center of the lens here, will be dictated on how fast the light travels through the glass, but also the angle of which it hits the glass. So if this angle was steeper, if it was a steeper angle, the refraction would be greater. If it was a shallower angle, the refraction angle would be less. So this distance from the center of the lens here to our principal focus, we are going to label as the focal length, Okay, so what we can do then is we can have different uses for convex lenses, and we'll talk a bit about concave lenses in a moment, but we'll stay talking about convex lenses for the time being. Now, one of the things to note with the convex lens is that we don't actually end up drawing the convex lens out every time like this. We actually just represent it with an arrowhead in this direction and in this direction, showing that the convex lens is getting fatter as we are moving away from the edges. So that is our symbol for a convex lens. So what I'm going to do is I'm going to draw a convex lens diagram here, and the ray of light which enters the center of the lens and therefore does not refract is called the parallel axis. And the parallel axis is going to be going through the center of the lens. So the refraction of light, which ends up hitting our focal point, the distance between the center of the lens to that focal point is called the focal length, which I'm going to give as f1. So this distance from here to here is I'm going to call f1. So one focal length distance. Okay, so what I could do then is if I start by having an object that is f1 and another f1, so f2, more than two focal lengths beyond the lens. So let's say for example, I'm going to have a large A as my image, as my object that I'm interested in looking at. Then what I'm going to do is I'm going to see what ends up happening to this object as it goes through. So what I'm going to do is I'm going to draw two lines that I'll do in a different color. The first line is going to go from this location here that I've just decided to choose because it's at the top of this object A. And so that's an easy mark to make. And I'm going to draw this going straight through the center of the lens and coming out the other side of the center of the lens, like so. That should probably be a bit straighter, but that's quite hard to do with a steady hand. Then I'm going to do another light ray that goes parallel to the primary axis, which, if we can remember, is this ray of light here, which goes through the center of the lens. And what's going to end up happening is then when this light ray here hits the convex lens, it's going to be refracted downwards. And remember, that refraction angle is dependent on the angle at which it enters, or the angle of this convex lens, and also the speed at which it goes through the glass. So that is then going to angle down as it enters, and also angle down as it passes out. So that's going to look like so. So then what we end up having is we end up having a situation, let me just try and make that line a little straighter. We end up having a situation where the top of that A here will appear, and let me just get rid of some of this so it's a little bit easier to see, in this location here. So what's ended up happening with a object, which is my large letter A, placed more than 2 focal lengths, so f2 plus, beyond the center of my lens, is I have created a inverted image that is also smaller in size than the actual real image, or sorry, real object at this location. So I've created an inverted image that is diminished, and that's the word we're going to use to explain that it has got smaller. And because these two light rays actually meet for real, and if I was to technically put a projector screen or a screen here, then I would actually end up to actually be able to see the image of that object A. I'm going to say that this is a real image. And this is an example of how a camera works, or for that matter, actually the human eye when it focuses on something. Now, what I could do is then I could move this A into a different location, and I could move this A between f1 to f2, so between more than 1 focal length, but not more than 2 focal lengths. And if I was to do that, and I was to draw a letter, let's go with letter B here, let's see what ends up happening. So if this is my letter B, I'm going to have 2 lines again, and I'm just going to get rid of these so it's not too busy. And my 2 lines, one line is going to go through the center of my lens. Let's choose the top of the B like we did last time. So I have my center of my lens line, like so. And then I am going to have my refraction line, which enters parallel to the parallel axis, which is then going to end up refracting. So this will end up refracting, again refracting at the same angle, like so. Okay, so then what's happened is I've had this producing the top of the B in this location down here was here. So what's ended up happening now is I still have an inverted image. This time, however, though, it has been magnified. So it is inverted, and instead of diminished, instead of having changed into a smaller size, it's actually got larger, so it's a magnified image. And as well as that, because these 2 ray lines meet, it is also going to be a real image. And this is an example of a projector. Okay, then what I have is I can have another situation where I have the object that I'm viewing within 1 focal length. So this would be f1. So if I write down, say for example, an object that I'm going to call object C, like so, if you just pause the video for a moment and see if you can attempt to draw the 2 lines which should come from that point there, and if you can remember where those 2 lines go, and see if you can recreate what should end up forming probably at this location here somewhere. Okay, so hopefully you can recall that one line goes through the center, like so, of the lens, and that the other line runs parallel to my parallel axis, and then it's going to refract again at the same angle. Now this time, what's going to end up happening is that these two lines are not going to meet. So if they're not going to meet, the first thing we can say about this F1 situation is that it is going to be virtual. The next thing we can say is that this C here ends up being here. So actually we end up with, sorry, that's probably a little bit more like that, coming down. So we're going to end up with the top of the C in this location. So the image is actually now upright, and it has also been magnified. And this is an example of a magnifying glass. So we have a magnifying glass which we can use that's going to create an upright, magnified, and virtual image. Virtual because the lines are not going to meet. Magnified because, as we can see, we have got a larger image than the actual real-life object. And upright as these lines have not ended up crossing over, and so this location and this location end up being in the same upright position. Okay, so if we just have a little pause there, and maybe pause the video and try and familiarize yourself with these different scenarios, and we'll have a go at doing some questions. Okay, so if we have a go at this question here, so let's say, first of all, could you draw that line and draw me the symbol for a convex lens? Okay, hopefully you've done that, and we can remember that our symbol is like this. And then can you pause the video, and on your piece of paper, can you draw whereabouts the principal axis would go through? Okay, so hopefully you've done that, and that would be straight through the center. And could you name, if this was the refraction, could you name what that location is there? And then also could you name what that distance is from there to there? So that has a distance name, and that also has a name. Okay, so that is going to be the principal focus, and that is our focal length. So I'm just going to get rid of that. And then what we've got is I'm going to take that focal length, which is from there to there, and call it F1. And I'm going to place the same distance here, F1, same distance again, F2. And I'm going to then place a picture of a man at this location here. So now could you pause the video and show me how you draw a lens light ray diagram showing this object here passing through the convex lens, and what three things could we say about that image that is created? Okay, so if you've done that, and we can remember our first ray of light ends up going through the center of the lens, like so, and our second one runs parallel to the parallel axis, refracts into that situation there, and we end up with an upside down inverted image, which should be, sorry, I haven't done a very good job of making that look diminished, but it will be diminished like so. And that is also going to be a real image, and that is an example, if you pause the video, of what's a real life example of that. Okay, hopefully you've had a guess, or you're correct in saying that it's a camera. Okay, then I want to pause the video and explain the next two. So if I put the man in this location here, could you draw a light ray diagram to explain what would happen and the image created, and then finally do the same for here, light ray diagram, what type of image is created, and give me two real life examples of this location and this location. Okay, so hopefully we've done that. So we start firstly with this one here. First ray of light is going to go through the center lens, next one is going to run parallel to the principal axis and refract down in exactly the same manner as the other ones. Then we end up creating a magnified, so a inverted, as it's upside down, magnified and real image, and that is an example of a projector. Then in this situation here, and I'll leave that one on there because that's going to actually stay the same. This here, I will have this going through the center like so, and that will end up creating an upright, magnified and virtual image, and the example of that is our magnifying glass. Okay, so now we're going to talk about concave lenses. The concave lens is now thinner on the inside in the middle of the lens than it is on the outside. And so if this is the center of the lens here, we're going to have our principal axis running through the center like so. And then what's going to happen is that light is going to refract now in the opposite direction, because we are going to have this part of light here entering the glass first and slowing down, so therefore refracting light upwards, and the same thing happening again here, so light is going to refract up. And then the opposite of that in this part of the lens, so that we end up with light now spreading outwards. Now you can see that in this location here, we're not actually going to have a principal focus forming, but actually if I take these lines and I draw them dotted back in this direction, and I'll end up with a principal focus on the other side of the lens. And it's important to note that any images created are therefore going to be virtual, because the two lines are not actually meeting for real. Okay, so what we can get with a concave lens is the same idea as what we had before. We're going to draw, and it doesn't matter at any location, doesn't matter the focal length that I place this object, but let's say for example I had a man that I would place here. I'm going to do two lines. One is going to run through the center of the lens. I'm just going to change this and see if you can remember, or by using your logic, write down what you think the symbol for a concave lens would be. So symbol for a concave lens would be the opposite, so it would be this. And I'm going to do my two lines, which is going to be one going through the center of this lens, like so, and then one running parallel to the principal focus, and then refracting upwards like so. Then what I'm going to do is I'm going to pull this back with a dotted line, and I can see now that I would have my man appearing in that location. So the top of the man's head would appear to be there. Now, first of all, as I've already said, that would be a virtual image, because if I put a screen there, those two rays of light don't actually meet. That is also a diminished image, as well as also being upright. And it is going to be irrelevant as to my focal distances, because that's just going to stay the same regardless of where that man is. An example of that would be a peephole in a door. So say for example, when you have a door, and on one side of the door you have a little hole which you can view through, and you'll end up seeing a small image of the person on the other side of the door, and you can see the entirety of their body as a result. Okay, so if we just pause the video and see if we can have a go at the moment at just putting this together and writing down from memory what we would have if we have this situation here, F1, F2, so that is person A, person B, person C, and then finally we also have person D. So if this is our lens in both cases, could you write down A, B, C, and D? What 3 types of images would be created with each one? And could you give an example of each one as well? Okay, so A is going to be inverted as well as diminished and real. B is going to be inverted, magnified, and real. C is going to be upright, magnified, and virtual. And D is going to be upright, diminished, and virtual. An example of A would be our camera or our human eye. Example of B would be our projector. Example of C would be our magnifying glass. An example of D would be our peephole in a door. And finally, just to finish this off, let's see if we can do a final light ray diagram for this concave lens and showing the image that would be created as the result of the back of this. Okay, so hopefully you have put one line through the center of the lens, one line which will refract upwards, our dotted line that goes back to see the man's head in the new virtual image created like so. And then also let's finally just have a go at our concave convex lens, and let's put a person 1 to 2 focal lengths. So that's f1, that's f2. So 1 to 2 focal lengths, so this would be our projector, and see if we can do a ray diagram for this. So one line through the center, one line to the parallel axis, and then refracting. And then we will end up with a magnified, should be magnified. I've done a very good job of making that look magnified. Magnified, inverted, and real image. Okay.